Yeah, hi, good morning. For today, our team will be presenting about the instruction set and assembly language programming for problem-based assignment computer architecture. Okay, so content for today is a group member, question 1A, question 1B, and reference. Okay, okay, so this our group member, Muhammad Syamur Ghani bin Mir Ramadan. And the second one is Muhammad Zainal Ghani bin Muhammad Yusuf. And the third one is Muhammad Faris Hakim bin Muhammad Fazli. And the lastly is Akil Hajar bin Ahmad Faisal. Okay, so this question number one. The question is a computer architecture student taking part in a lab simulation of Motorola 68000 microprocessor using EZ68K simulator to help him understand how data is accessed in the memory of should register. Using EZ68K, here are tasked to write an example program of a basic arithmetic program that uses a different addressing mode. The example program should contain move ADD and sub instruction and commands.
Hi, good morning. My name is Mohammad Zainal Ghani. Okay, my question is define the addressing mode. Addressing mode is how a microprocessor locate data operands from instruction, whether in a register, memory, or within the instruction itself. In the Motorola 6800 common addressing mode are immediate data. Immediate data is part of the instruction register direct operate stored in a CPU register. Address register indicator address register point to operate in memory. Absolute operand located at a specific memory address. Okay, that's all for me. Thank you.
Hi, today I would like to answer the question 1A Roman 2. List are the addressing modes in M6 8000 processor. The answer is data addressing modes, absolute addressing, direct addressing, indirect addressing, program counter, relative addressing, and also immediate addressing.
Hi, for question number three, the question is give an example of a M68000 assembly program that perform addition of two numbers using at least three addressing mode. First, the value of 10 is moved into the register D0 and the value 5 is moved into the register D1. The instruction ADD D1 and D0 add the content of D1 and D0 to D0, resulting in D0 equal to 50. Next, the instruction is LEA num1 A0 load the address of variable num1 into the address register A0. The value store of the address, which is a 3, is then moved into register D2 using the instruction move W A0 and D2. After that, the instruction ADDWD2 D0 adds the value in D2 to D0, producing a total of one, total of 18. This finally result in state in the memory location result using the instruction move W D0 result. Finally, the label num1 and define a contains value of 3 with the direction DCW3, while the result reserve 1 word of memory space to store the result using DSW1. Thank you. So after you do all the things that I said before, this is the answer. Okay, thank you.
Hi, my name is Muhammad Sabul Ghani and Assalamualaikum. I will explain question number 4 and question 1A Roman 4 and question 1B 1 Roman and 2 Roman. So this is question 1A Roman 4. So the question is, give examples M68000 assembly program that performs subtraction of two number using at least three addressing modes. So as you can see on the photo, that's the coding for the calculation for this, and this is the output. So when you put the coding that I talked about earlier, so this is the output that you will get later on when you insert the coding on the assembly program. So that's the answer for question 1A Roman 4. Now I will talk about question 1B. So the statement is, a student learned how logical and arithmetic operations are performed at the assembly level using Motorola 68000 processor. The instructor was asked him to explain how basic logical instruction work in practice based on figure 1 below using Easy68K simulator. So let's go to the question. So this is the question 1B Roman 1. The question is, describe every steps of the assembly language of figure 1 on the earlier figure using Easy68K simulator. So that is all the step. So first is you need to describe every steps of the, you need to put the origin. So we got the origin like in the photo. So that's the origin. Later you need to include how to, in what term do you need to move. So in these questions, the terms that we use is move in the term of word. So after that we also have not, which is the, like to invert all the bits in the D1 operation. So as you can see, that's the all the following steps. It follows step by step, and if you put it step by step like that in the simulator, you will get the output like this. So this is what happened when I follow the steps that I showed earlier, and I put it step by step on the simulator, and this is the coding that will look, this is how the coding will look like. And the output when you put that coding will be like this. So this is the answer that you will get, and this is the answer for question 1B Roman 1. The next question is question 1B Roman 2. The question is, list all logical and arithmetic instruction in 468K assembly language. So we got two types of the question. We got two types. One is logical and the other is arithmetic. So as per the instruction, the logical is the one on not. If you see on the steps earlier, I include that. And the description is bitwise, not and or is an operations. So after that, we also get the arithmetic. Arithmetic equal to more like a mathematical solution. So in the steps that I showed earlier, I include this one, which is add in the terms of word. And as you see, addition and subtraction is operation for the mathematics solution. So that's all from me. Thank you, everyone.
Next, I would like to answer the last question. Question 2A. The question is, convert the expression below into an assembly language instruction. The question is 1011111 with 2 times DA base 16 and plus 1234 and base 8. First of all, this is the manual calculate that my team do. Uh, first of all, we need to convert the octal number to the hexadecimal. And after that, we need to set origin, that is 8000. To that, we need to multiply the O by D1 and also add the hexadecimal constant to DO. And lastly, we get this answer. That's all.